Hello, and now I'm going to be showing you about different linkages and dynamic in the topic of dynamic mechanism. So as you can see here now, I have a line drawings of most of the things. You have like pivot points, crank and sliders, and linkages. So from this, for most of the linkages questions that you'll be focusing for, will be kind of almost like a trammel. You'll be finding fixed distances as it rotates around a certain degree of movement. So linkage would be set to a certain degrees, and we're trying to find out the resultant motion of it. So the first thing I'm going to show you is going to be this one here. So as you can see that we're going to be having a crank and slider. So there will be a crank rotating around this circle, but will always be moving along this line. So the distance between the crank is always going to stay constant. So as you can see, this line, this line, this line, and this line are always going to remain constant. Also these ones as well. These are all the same length. So I can prove that by going, they're all 246 long. 246. Okay, then we'll have a point on these lines a certain distance away, and that will be remain constant as well. So you can see that the distance from here to here is 123, and then from here to here it's also 123. So we can follow this along by continuing on the circle. So we can say we can have another 30 degrees, and then the distance will stay the same. So we can take a distance here, move it down, and join the line up again. So this will be our new length, and then we can get 123 again. So this will be the length, almost like a trammel. So we're taking fixed distances to find these points, and then we can push this one on here, and we can see that this point here will be the next one, the next location on this. So the resultant motion will continue on like this until you can see the final result. So the spline will continue on this path. Bang, bang. And then it'll eventually end up back here as well. It'll probably make a path, something like this would be the ending of the path. So you can see how it would create the resultant motion there. The next one I'm going to show you is going to be a ladder fall, and these all follow the same principles. So on this one here you can see that there is this black line here with the ladder lining up against the wall, and that as it falls down the wall it will be moving further and further away. The fixed point where someone would be standing then would be his ankles almost tracking to the ground. So that's if he stood still, how he would track. So you can see that we could find another point then by doing constant distances. So we know that it's 170 large. We can move that down. This is our new part, new line here. And then we can take the distance again, which is constant on all of them. So as you can see, it lines up again here with the ending. So even though it looks like these might be getting smaller as it falls down, that's just because the angle is decreasing. So this circle here and the circle here are the same size. They're always the same all the way down. So even though it looks like it is falling at a kind of less and less and less, the actual points are staying the same. That's why these kind of linkages questions always move around stuff like trammels, where you can have a constant distance, fixed lengths, and that's how most of these questions go along. That's all I have to say on cycloids now, or on linkages now. Thank you and goodbye.